This solid is a prism, and every prism has what we call cross section. How do we identify a cross section? Cross section is a plane shape that appears on opposite sides of the prism. For example, it can appear left and right and equally spaced. It can appear front and rear, the front and the back are equally spaced, or at the bottom and top and equally spaced. Now, if you look at this rectangle EABF and rectangle HDCG, both of them are equal in size. However, they are not equally spaced because the gap between them at the bottom, that is AD, is not the same as BC. That means the two of them are not equally or uniformly spaced, meaning that we don't have a uniform height across in between them. So what can we use? And if you look at the triangle at the base, the rectangle at the base rather, that is ADHE. And this one are FBCG, the rectangle at the bottom and the one on top. The two of them, of course, they are equally spaced. The gap between them across is the same. However, the two of them are not of equal size. Hence, you cannot choose it as cross-section. Now, what can we now recognize as cross-section of this prism? Let us look at this trapezium here. This trapezium, that is ABCD. And the other trapezium that we have there, or this trapezium in front are the one at the other hand, at the back. The two of them are of equal size and are equally spaced. The gap between them, since FB is same thing as GC, same thing as HD, and the same value as EA, that means the gap between them is the height of the prism. The height of the prism in this case is 4. Height equals to 4. So to find the volume of this prism, we simply say volume equals to area of cross-section times height of the prism. How do we get area of the cross-section? Find area of this trapezoid. So the area of the trapezium is simply A equals to 1/2, open parenthesis, AB, A plus B. This A and B here refers to the two parallel sides of the trapezium, so times height of the trapezium. And that gives 1/2 into our A is BC. That's the first parallel side of the trapezium. That is 8. So we have 8 plus B is the other parallel side facing it. That is 12. Times the height of the trapezium. The height of the trapezium, that's the gap between the perpendicular distance between the two parallel. That's what is given outside here. And that is 5. So if we simplify this, we have 1/2 multiplied by 12 plus 8 is 20, multiplied by 5. But 2 goes in 20, that is 10. If you use 10 to multiply 5, you have 50 centimeters squared. That's the area of the trapezium, which happens to be the one of the cross-section of this solid, of this prism. Hence, we can find the volume. The volume of this prism becomes V equals to area of the cross-section, that is the 50 we got, times the height, the gap, the perpendicular distance between the two cross-sections, which is this 4, FA, times 4. And that means 50 times 4 will give us 200 centimeter cube. That's the volume of this prism. And we go for A.